Final filtration or ultra-filtration is our next. As we've followed this drop of water and we've gotten into more and more detail through all the modules, we're kind of at another of these end-use components that's really important. In your design guideline, Peter, you make a few statements, and I just want to dive into those a little bit more. So the first one is that filtration should be considered in the context of the entire rainwater harvesting treatment train, as we've talked about both in your guidelines and really this whole course, right? So that's the first sentence you say.
Absolutely, Michelle. We're talking about a rainwater treatment train. And I'm glad you mentioned that, because filtration actually gets quite confused with people, where they think they have to hit the system in one place and do really fine filtration. But if you do that at the wrong place in the rainwater harvesting system, all that happens is your filters clog up and you don't get the answer you want. So when we did the pumps part of the course, we talked about how it was usually 30 to 20 micron coarser filters just before the pumps to protect them. But there between the pump and the rainwater storage. So that's part of the treatment train, isn't it? Because it's not too fine that it'll clog up, but it's actually taking out a fair bit of material if it exists, because 20 or 30 microns is still pretty tiny. You can't really see it with your eye, or you probably could if your eyes are better than mine, but I'm older. But because it's not trying to take out all materials all at once from your rainwater harvesting system, it makes it easier at the end use for a different level of filtration.
Right. And understanding that, your tank is a bioreactor, and that, you've got these hot water supply systems, and we've got, all these things that we're doing, and we're not just attacking the water at its end use with one manufacturer box type solution, right?
If you try and attack the water at one place, you won't succeed. And this is what we've talked about all through this course. And, there's a bit of a dichotomy here, because in a lot of the regulatory advice and standards and guidelines, they're really talking about attacking this at one place. Hopefully by now in the course, everyone has realised you can't actually solve this problem in one place. You need to understand the treatment train that's actually happening, the natural things like the tank bioreactor, the biofilms, the settlement processes. We also need to understand how water quality changes as it passes through that system, and how the components of your rainwater harvesting system all act to remove part of that problem. So if you've got screens on the inlet to your tank and you have a leaf diverter, that's changing what goes into the tank. If you understand that there's a 20 or 30 micron screen, where it would be a Y filter or a screen directly in the pump, around your pump, you realise that even more material is taken out there. So by the time you get to the end use point, provided we've done a good rainwater treatment design, if you choose a very fine filter on your tap, it's going to work okay and not clog up, because there's not much left in the water. So in my own house, I have a 0.1 micron filter with activated carbon. It comes in a little cartridge that sits under the kitchen sink. And because it's a fair bit of energy loss to do that, it's only on my kitchen tap. It's not on every other tap, because when you think about it, it's not needed for every other tap. So I've just got it for drinking and cooking. So
I'm curious, what is the pressure drop across the filter like that? Is it about, is it 5 psi? What is that in kPa?
It's
quite a bit.
Quite a bit. It's substantial.
Yeah.
Once you're getting down to 0.2 micron or 0.1 micron, you do not want to put that size filter on all supply. You actually want to put it on where it's really needed. So you actually don't need this for the washing machine or the garden or the toilet. You don't need it probably for most users in the house. you might need it. It's not essential, but you might need it on your
Mm-hmm.
drinking water tap, for example.
Mm-hmm. Yeah. So what you have in the design guideline, you have a zero point 0.2 micron filter with activated carbon could be selected for drinking water. This would remove a range of chemicals, minerals, organics, and microbes. And I don't know. I'm curious on your choice of wording there. Could be selected for drinking water. Any, you know, what's your thoughts there?
My thoughts on that are quite simple. When we wrote this national guideline, I had a very conservative committee, um, and they all represented manufacturers, and I was appointed as the chair of this committee and the scientific expert because all the manufacturers in the rainwater industry are trying to sell their products. So two of my committee sell products like UV devices to for treatment of rainwater and chemicals to put in rainwater. So took 3 years to write the guideline because the rainwater industry is usually, and you have this with ARCSA, usually made up of people who need to do their rainwater harvesting and then people who want to sell products into the rainwater harvesting industry. So it's actually a
Mm-hmm.
very interesting tightrope we have to walk, and we've been walking through this with this course. If you say the water quality is really bad, it is falsely perceived by some manufacturers you'll sell more products to clean it up. But what really happens is less people actually want to do rainwater harvesting because it frightens them. So the beauty of this sort of course is to get people the facts about rainwater harvesting. So on this committee, the word would and could was subject of a year's argument. Um, you can, and there's also and there was a show of hands in the end. If you talk to your local water authority and they've got a 1 micron ultra-filtration plant, they'll tell you that your water quality is perfect. So you
One mic, 0.1 micron.
0.1
Yeah.
micron or zero point 0.2
Yeah.
even. So
Yeah.
you've got this dichotomy of views which we're navigating in this course. So our
Mm-hmm.
objective in this course is to give people the facts so they can make their own decisions.
Mm-hmm.
For many years, I actually didn't have a drinking water tap filter because I trusted my treatment train. Later in life, I put one in, and it's great because when we're using mains water, because we've got a dual water supply in the city, it's also taking out all the other chemicals that are in mains water, which makes us very happy. So it's working for both water sources.
Mm.
The other thing to be aware of, the mainstream water industry tests these things. So if you've got distributed systems that treat water, they're in competition with utility supply. So it's quite very difficult to get money to test these things and go and jump through all the hoops to actually get the quality. Fortunately, during my PhD, we tested this at my house, the zero point 0.1 micron one, and we always had nothing at the drinking water tap. Some issues though, because I'm not very organised, as Michelle will tell you. Um,
We make a good team.
so what we make a great team. Uh, we're doing well in this course. So the manufacturer of the device I've got on my house, she sends me an email once a year, and then if I don't respond in a couple of weeks, she calls up my wife Janine and says it's about time to change your cartridge, and I've sent one in the mail to you. So we're using an external provider to remind us that once a year we need to replace this cartridge. So these things are great, provided you realise that um, you need to replace them regularly to keep working.
Awesome. Send me some information on the particular model that you have. That would be. I'd be really interested to know which one you use, and I'll put a link to it in the supplemental resources. If there's any others that you have experience with that you think are great, ultra. By the way, what is the definition of ultrafiltration versus just filtration? What is the micron size?
Actually, there's filtration, there's microfiltration, there's ultrafiltration, and there's nanofiltration.
Okay.
And
am I correct that 0.2, 0.1 are both considered ultrafiltration?
0.2 and 0.1 would be ultrafiltration. 1 millimeter would be microfiltration, I'm assuming. But 0.2 might be the cutoff between micro and ultra. So I might take this on notice, and there's a table I have somewhere. So, for instance, in the laboratory, when I'm doing my microbiology tests with Rainwater, the little filter I use to trap bacteria when I'm filtering the water is a 0.2 micron filter, which we place that onto the agar plates and we see what grows. So this is what we do. So 0.2 is probably micro, I think, Michelle, but we can check on that.
One last thought I'm having, I don't know, because I haven't really looked into these micro or ultra filters. If flow rate was an issue, could you not put two in parallel to get a faster flow rate if you needed that, right?
This type of filtration, and you're trying to push a whole house supply through it, you're going to be using a lot of pump energy. There's a fair head drop, pressure drop across them. So you really want to have them only where you need them. And you really only need that on your drinking water tap. So I think the next point is quite useful to.
But the challenge, and I know Canadians are possibly going to run into this, is just trying to balance what the regulatory or what the legislators are saying is required, right? Versus kind of what we're presenting in this course, this evidence-based, research-based approach to rainwater harvesting. And there's going to be times where you might be faced with a decision like that.
It is a good point, Michelle, and I think fortunately we're giving people the evidence base to work from, and then they can. And we've actually given people advices on how to interpret what the regulators are really trying to say. Because after you've done this course, and if you start looking at what the regulators are saying, you'll realise that what they're saying is not as clear cut as it seems to be. So this course should be helping people to navigate what the regulations are really saying. However, there are places, particularly in Canada, in some provinces, where depending on which individual you're dealing with, you'll have different interpretations, including, you need to have very low filtration on everything. That would be difficult because you don't want this low filtration on everything, remembering you've got 20 or 30 microns at your pump anyway. So sometimes I think the best outcome of this course is people doing it are now able to actually talk to their regulators, say, oh, no, I've got this filtration on my tap. And this is the treatment train happening in my rainwater system, and I've got a leaf diverter, and I've got screens on the inlets. So there's a whole train of what we call in health sciences a multi-barrier approach going on here. You still might lose that argument with certain individuals. So now you have to be.
Oh, you won't win. You should say you'll still lose it. You won't win. Yeah.
But your rainwater harvesting system will be better. So that'd be good. So at the other end, you're in this dichotomy of, do I need a lot of pump energy to push rainwater for the whole house through this very low filter? Or you can step back and you can say, and it was in one of those tables, I was thinking about this, Michelle, that we looked at earlier on, Yeah, for drinking
Mm-hmm.
water use, you need this sort of filtration, uh, but for this other
Yes.
use, you don't. So the point 0.1, point 0.2 micron filter would be for
Yeah.
drinking and cooking, but it definitely wouldn't be for
Mhm.
toilet flushing and showering, for example. So
Right.
you you can sort it out that way as well about human contact. Um,
Mm-hmm.
you can actually navigate this so you're not putting a really fine filter on your entire water supply, and therefore
Mm-hmm.
you, you're not forced to use a lot of pump energy. So you can navigate the
Mm-hmm.
standards based on what we've said.
Mm-hmm. Great. One last statement that I really liked. It was that the choice of water quality solution will also be dependent on the circumstances of people within a household. And I like that because it is actually not often the stance you see from a lot of these regulations and this perspective, the other perspective.
Well, you know, true or not, um, and certainly true for immunosuppressed people, people who are ill or elderly, we need to be more careful about our water quality. When we're fit and vibrant and young, our body is really good at protecting us from challenge, a lot more than people realize. There's too many ads on TV about disinfecting everything to protect our children, which is just total rubbish. The reality is humans have great immune systems, and um, in the middle of their life, they're quite robust to most sorts of challenges. But when we're very, very young and old, we need to think about um, uh, we're less able to be challenged. I may clarify young though, we can make our kids too clean and then they end up in hospitals all their lives. So they up until the age of 7, children develop their immune system, so they have to be challenged. That's why little boys go out in the garden and dig up dirt and eat it and things like that. It's. I'm not saying that's why. That could be. Um,
Mm-hmm.
you
Mm-hmm.
you need to children need to develop an immune system based on challenges. If we keep them too clean, they never do that. But once we're elderly, our immune systems are not as robust as they used to be. So, elderly people in your house, let's say someone in your house has MS or some other illness that means their immune system is compromised. We need to think more carefully about our water quality treatment. So, in those circumstances, elderly or someone with a disease that compromised their immune system in the house, you would certainly have a point 0.1 micron filter on the drinking water tap. You'd do that,
As compared to nothing at all. Is that what you're implying? Okay.
and
Yeah.
and also household circuit. My friend in Western Australia, who's a great advocate of rainwater harvesting, his whole house runs on rainwater harvesting. He put in a UV filter because him and his wife just had two little babies, and um, he just wanted to put this extra bit of treatment in just in case, even though he didn't think there was a problem because he had
Mm-hmm.
tiny babies in his house. So people make decisions for different reasons. So we need to think
Mm-hmm.
about the components of our household. I've got the zero point 0.1 micron filter because we're getting older, and my wife said I really need to. Um, I want you to put this filter on just in case. So our we need to be mindful of the makeup of our households, and we need to choose our water quality solutions based on the makeup of our household. And you won't see that in most design guides, but
Mm-mm.
it's a socio-economic thing. It's also understanding the medical context of the members of our households.
Great. Thanks, Peter.